Okay, can you hear me? Yes, I think so. Welcome to this talk. It's about geospatial event detection in the Twitter stream. You will find out what exactly I mean by that during the talk. It's probably a bit different from other talks. I mean, it's also not about Elasticsearch, like the talk before. It's not even about Hadoop. But it's about social media analytics, and there's an awful lot of data out there that need to be analyzed. And you need quite a bit of intelligent methods to do that because it's textual data and so on and so forth. And I'm just going to give an example about how we do this, and I hope you can take something away from that. So it's a very specific scenario that we're focusing here. It's about a command and control center. I'm going to tell you in a second what that is. We have a certain approach of how we deal with this. First of all, we try to identify hotspots. That's like certain spots where lots of tweets are coming from, and then we use a machine learning approach to figure out whether there's really something interesting happening there or not. And I'm going to present some evaluation results and look in the future. Okay, social data. So social media continuously creates massive amounts of data. There are 500 million tweets each day. That's about 300 gigabytes of data just coming in every day as a constant stream. And the nature of the data is also rather special. So it's time-stamped, first of all. That's something you can work with, and that's something you should work with, because like usually people are interested what happened now or just like recently, and not so much what happened like 5 weeks ago. It's textual data. It has really many languages. There are all sorts of lingos and slang, so you can't really, using a dictionary on this data is very difficult because sometimes it just doesn't work. You have spelling mistakes, a lot of them, because just people type this on the go. And you have only a few words per tweet, which is also like a huge limitation. If you, for example, want to detect the topics in a certain text, like if you have a newspaper article and it's very long, you have like lots of chances to find words that can tell you what it's about. If you have a tweet, it's just like very short, and you have very fewer chances of actually figuring out what it's all about. It has links to pictures. So you might want to follow these links, so you have to take account that, because that takes some time, kind of like catch the HTML document, kind of like, extract a picture from it if you want to display it. You have links to newspaper articles, which gives you even more text that you should work with, and sometimes it's geospatial. That means like in some tweets, you have the exact coordinates from where the tweet is coming from. And that's, of course, very valuable information as well. It's about 5 to 10%. Or at least like, in the scenario that we're having. And so it's not easy to create actionable insights from this data. And in this talk, I just want to give one example about how we're doing this, and of course, there are tons of others. Okay, the company I work for is called AGT International down here. It's actually probably also a bit different from like other companies you have around here. So what they do is kind of like urban management and public safety. And so, cities today are complex and they need to be organized, and the administration is responsible to keep the population safe there. So that would be like emergency services, firefighters, the police department, the health department, and so on and so forth. They all have an interest in knowing what's happening actually, what's happening right now and where this is happening. And then you have like a command and control center down here. This is basically, the firefighters would have one, the police would have one, and this is when the 911 calls come in, and kind of like the services get dispatched and so on and so forth. So why I'm telling you this, why is social media relevant in this context? Well, it is. For example, look at this picture. This is an actual tweet, right? There's a plane in the Hudson, I'm on a ferry going to pick up the people, crazy. This was 5 minutes on Twitter before it was anywhere else. Next example, this is a love parade. I'm sure you're familiar with it. In this mess, like 21 people died, and pretty early on, like it was on Twitter. Like, the description of the situation, you could, like, if you just like, and that was actually like 3 or 4 years ago, and Twitter volume was much lower then. But you could get a pretty good idea about what was going on if you only would have followed that data. That's in Dutch here, which points out another problem, right? You get different languages. And then there's this, and this is what we are actually looking for, right? We're not really looking for these very big events, but rather for very small scale events. Here we have Hoboken is on fire, and there is a user giving the exact address and basically saying the building is burning there. And believe it or not, a lot of times people actually send out these tweets, but they don't call the firefighters, right? There was also when this when this soldier was killed in London recently, that was also a case in point. Like there was a picture on Twitter very early on about like the police basically arresting or shooting, or they just had shot the two guys and they were like lying on the floor and they were arresting them now. That picture was on Twitter very early on. There was no other picture of this. And if you look at the Twitter stream of the guy who posted it, you can see like immediately after the picture, it's all the news agency. Can we use this picture? Can we use this picture? Can you tell us more? Can you tell us more? What is the situation? And so on and so forth. And that is basically what we want to do. We want to filter out this information and kind of make it accessible to whoever the customer is, you know, firefighter, ambulance, police, and so on and so forth. And the technical term for this is creating a situational awareness picture. So that's basically what we will do. I'm not going to tell you all of that. I'm just going to focus on the first thing here. So we want to automatically detect whether something is happening there that we think like our customers should know about. We want to detect this, we want to classify it, and then display these events to an operator in the command and control center. It could be accident, fires, scenes of violence, demonstrations, and so on and so forth. Here's a little example of how this looks. I actually can show you the demo here as well. This is an offline demo because I can't connect to the servers. So, if you look at this is a map of New York. We're doing these experiments with New York just because there are an awful lot of tweets from New York, so that makes it easier to develop it. Then, of course, like, you know, if the customer is somewhere else, you need to port it. For example, here you can see here's a fire that has been detected. It's at the World Trade Center Memorial site. And then you can actually look at the picture. You just don't see much because there's like smoke here. I think this is a better example behind here. It's another fire. And there you have a picture which, you know, you can pretty easily see what the situation is all about, right? I mean, people are in this building and they have to leave this building because it's being evacuated. And their alarms went off and so on and so forth. So people are share this on Twitter, and that's what we want to find. And of course, like while we're doing this, and in the way we're doing this, we're finding lots of other stuff as well, which is potentially interesting to people, but not exactly in this scenario. Look at this. I mean, here's just like a music event. There's like the Rolling Stones playing, I think, and there's tons and tons of pictures out there exactly from this location. There's a certain big data gathering up here. People are talking about Hadoop. We would probably find this event. That's you know, there's some sport game, and there's another kind of like a pitching competition from startups, and you can see the winners here on stage. Maybe that's the other picture, and so on and so forth. Right? So that's basically the stuff that you can find. I mean, for the company that I work for, it's mostly these. You know, I mean, if something goes wrong, if there's a traffic accident, if there's a fire, and so on and so forth. What's interesting? Let's go back to this. So, I mean, these are the slides that I've just shown you in the demo, actually. So, what I'm going to talk to you about then is how we actually do this, and we have a two-step approach here. The first is we identify locations that have a high activity of tweets, and we collect certain geospatial tweet clusters. I'm going to tell you in a second how that works. Then we evaluate the cluster with a machine learning approach. So we want to figure out, like, is this actually real or something that we found there? And what is it that we found? Actually, what we have found is kind of like what we're working on in the moment. That is kind of like classifying the events according to the type, because you want to know, you know, is this a rock concert or is this a building that's on fire? Because that's, you know, different people are interested in that. So, as I said, I mean, there are like tweets that contain coordinates. And in the first stage here, I mean, basically we would work with those. And so, you know, they come in. Each yellow dot here is a tweet. And so, you know, they come in, we store them in MongoDB and kind of build up a geospatial index. And for each tweet that comes in, we would look, are there like more tweets around it? And here actually we found something. So I would kind of like look, oh, we have like 3 tweets from this location, so we kind of like store that. Here's another. It goes on then, and if something new falls in this radius, we kind of like add it to the old cluster. Here, It's slightly outside, but we still add it because we kind of think that might be the same thing. So, I mean, that is what we're basically doing in this first step. This is done, stored in MongoDB, and this is some geospatial indexing that basically allows us to do the search pretty effectively and efficiently. And at that point, we haven't really figured out much. We just know that there are these two hotspots. And then at that point, we need to look into the data itself. And you can see that there is like, this is one of the clusters we found, and this is another cluster. And you can see this here is clearly something that we're interested in, while this is not. Right? I mean, and the difference here is mostly that these tweets are about the same topic, whereas these tweets are about a different topic. Right? You can see this is more about Madeleine Albright playing the drums, and then somebody is saying that he wants to do some job apps, and kind of like, you know, something about the Emmys, and so on. This is completely unrelated. And this is just like people making first-hand observations and reporting them. So what we need to do then is basically we need to figure out that this is good and that this is bad, and that looks like a classic machine learning problem. So, yeah, we use machine learning to distinguish these two, and I will tell you in a second how exactly that works. Just like here's a bit of the architecture that we use, social media platforms who have an API, and then that's coming into our system. We currently only run this on Twitter, because Twitter data is, there's a lot of it, and it's freely available, and Twitter is actually really happy if people use their API. Now, you know, Facebook is always kind of like the thing. I mean, you know, if you post something on Twitter, basically, everybody knows that they're sharing this with the whole world, and so it's kind of like fine to use it. But if you're Facebook, then you know you can get the Facebook messages, but most people just set their privacy settings wrong, so you get all that stuff that you're not supposed to get, and that is that's a bit awkward. And so you know, I mean, just using Twitter is the better way here. There's a data retrieval module which just like fetches the tweets. We put them in a queue just so that we can deal, because sometimes the things with Twitter, they don't come continuously, but they come, you know, there's nothing for a few seconds, and then you get a huge batch. It's not supposed to be that way, but that's what happens. So it goes in a queue, and if it comes out of the queue, we pre-process it, and then we store it in MongoDB. We have 3 tables here: post, event candidate, events. Post is just every post that we get. We store it and keep it for 24 hours. After 24 hours, it's released so that the database doesn't get too full. There's a cluster creator, it's just what I've shown you, and a cluster updater, 2 jobs that basically try to figure out, are there tweets coming from a certain location, and are there a lot of them? If we find it, that makes up an event candidate. And then we have a cluster scorer, which I'm going to show you in a second. That's the machine learning part, which runs over each event candidate, and if it kind of like returns a good enough score, we put it in the event table. And everything that is in event table then can be displayed to a user, either in the web GUI that we have here, or like in this command and control center. And you know, that's the data visualization. So, and that's about the machine learning. 1 second. As I said, we have the tweet clusters. This is one example here, and then these are all the features that are computed on those. Because I mean, now we want to do the real intelligence. We want to figure out, like, is this, you know, is it good or is it not good? And the first feature that we use here is kind of like common theme, and it basically would just calculate an n-gram overlap between the different tweets in the cluster. So we have suspicious package here. We have like 4, 5, 6 occur several times because that's the train. Unfortunately, you can see that it's also a bit of a mess because you never actually have that exact string, because here you have 456, hashtag 456, hashtag 456 train. So you need to do some, you know, I mean, you need to, the tokenization needs to be fairly intelligent, but nevertheless, it can be done. So this first feature would just look trying to figure out whether there are words or phrases that are used in all tweets. And that's a good thing, right? Yeah. So the next feature is about duplicates. Duplicates are usually not good, because if there might be retweets or any other thought of like people passing on one tweet and just like, you know, forwarding it, maybe sometimes the retweet is just missing. So if you have duplicates, then basically it's not a first-hand observation. It's just like somebody just passing something on, that's maybe not what we want. Especially if you have a tweet cluster where everything is exactly the same, right? We have a bunch of sentiment features which are fairly simple. We just have dictionaries about words that are positive and words that are usually about negative emotions. Emoticons are in there. They usually help, actually, with the words that are a bit difficult. And we just would look, does this cluster overall contain more positive words than negative words, more negative words than positive words, and so on and so forth. That might be important because, if you have an event like a rock concert, you can expect people to be rather positive about it. If there's a fire, probably they're rather negative about it, and oh my God, and horrible, and so on and so forth. So that helps to figure out what event you're dealing with. Subjectivity is more like an experiment to figure out, whether people are talking about something that happened to them or something about general. Are they just forwarding a newspaper article? So here we look for personal pronouns. I am, doing something. And so on and so forth. Present tense goes in the same direction. This is about, verbs in the present tense, reporting that people are experiencing something right now that is here, rather than yesterday I did. That would be not what we want. And we have a bunch of ratios. We let the machine learning algorithm, of course, figure out whether they help or not, like how many hashtags are there in there, what's the ratio of ads, what's the retweet ratio, and we have certain semantic categories. It's just like dictionaries, about sport events, about fires, that basically help the machine learning algorithm to kind of like figure out what type of event it is, and also whether it's an event or not at all. And these are all basically working on the text, and there are just like certain other features we have here. Just the link ratio, how many links are actually in there. We can figure out whether something is from Foursquare or not, because Foursquare tweets have a certain structure. They're always like I am, and things like that. And of course, if something's from Foursquare, that also indicates certain categories, and others probably not, because people wouldn't check in at a car accident, right? That's not what you do usually, but you might check in at a rock concert. Generally, how many tweets are there? And this is also an important feature, as we will see, from how many different posters do we have them, actually. So if you have like this, and this is all from the same person, that's good. But, if this comes from 4 different persons, and basically have 4 persons that are at this location, they're all reporting the same thing, that is pretty good evidence that something really is happening there. And you get lots of these things all from the same person. There's somebody sitting somewhere tweeting and reporting every 5 minutes about his lunch, right? Also not terribly interesting for us. Unique coordinates is to sort out bots. If this would come in and all the coordinates are slightly different from each other, then that's a good indication that people are really using their mobile phones, because they're not really 100% exact. But if the coordinates are exactly the same, then probably there's just a robot tweeting, and it's hard-coded to code from to send this out from these coordinates. Not what we want. And we have some special occasions, because we know that people tweet usually when they're bored, and they're bored when they go to the train station or when they're at the airport. They just go there, they start waiting, and they would take out their Twitter and kind of like read through it and retweet it. And so from train stations and airports, we would get like lots and lots of tweets. So we have to take this into account, just like because there's not always something happening there if people are tweeting a lot. Okay. So that is basically all the intelligence that runs on the clusters. And we use a machine learning setup for this. And the thing here is basically what we're using is Weka, right? So Weka, for those of you who know it, it doesn't scale. It doesn't scale at all. Nevertheless, it works for us, and here's just why. Machine learning, or traditional offline machine learning, falls basically in 2 phases, right? We have a training phase. This is when we chew through all the data, and when we basically create a predictive model. That is like the blue part here. And then like during execution, we have like the green part here, that is during runtime, and everything that is done is kind of like applying the predictive model. The predictive model can be very simple. And so if we train, we have like quite a bit of time available to us, so we can use Weka, although it's not really great and fast and scalable. And but that's okay. We just like set a few some time for it aside. It will create a model, and we just have to run the model during execution. And then we use decision trees. So that would be the output of Vector that you get after you run it for a while. And then what you can do is just like you can take this decision tree and port it into the language of your choice. Right? This here is C#. Company likes to use C#. And, I mean, this is a direct translation of the decision tree, and that is nothing else that is happening here. These are all the features, and then we have calculated certain weights for the features. And this, for example, says if this unique poster total feature is below a certain threshold, then return false, so it's not an event, and don't even bother to go further. And, there are other paths here where it gets more complicated. And as you can see here, this code is only this upper part, and I mean, it gets rather complicated, so this can get quite long. That, of course, is not all that you can optimize out of it. There is a nice paper out there by Jimmy Lin, who is coming directly from Twitter. They use this approach a lot, and what you can then do is kind of like run all sorts of optimizations over it, and even go to the compiler, and because the compiler tries to optimize such code, and especially kind of like when it's coming from machine learning, kind of like know which path the compiler is likely to take, but the compiler makes its own assumptions, and sometimes they're wrong, so you can help the compiler with certain settings to kind of like, what to load in and what to store and to cache and whatnot. It's a fairly new paper from Twitter, so if you're interested in that, it's a good read. Okay. So this training that we did, this is also like, of course, a reason why Vector works for us very well, is because we only had 1,000 hand-labeled tweet clusters. So basically what you need to do for each of these clusters, or for a set of these clusters, for each one you need to know whether it's good or whether it's bad. And that needs to come from somewhere. So somebody has to look at it manually and say, it's good or it's bad, and so on and so forth. And we did this with 1,000, like ourselves. If you want to have it larger, you would go out to Mechanical Turk or use some online approach. I'm going to talk about that in a second. So we did this by hand, just me and a colleague of mine, and we got like 319 of them were good, and 681 were bad. Then you use cross-validation. Usually that's just the standard approach. And if you use a decision tree, we get to these predisposition and recall numbers, which are really very good. But as we will see in a second, there's a problem with the recall number. So yeah. What we then also can do, this is also nice, we actually can take a look at the data that we have, and we can see which of the features that we actually set up, which of them does work and which of them do not work. And yeah, that way, I mean, just basically figure out what works and what doesn't, which is always good to know. And this is basically the outcome then. I talked about these two features earlier on. We have this common theme that is basically people using the same words in different tweets. And we have like unique posters that is like the tweet has more than one author. And a one here is basically, I think it would be 10 different people in a tweet cluster, and common theme up here with like 3 words that really frequently occur. So this is just like a formula behind there. And what you can see very clearly is that if we have lots of different people posting from the same location that nevertheless use the same words, then we're up there in that region, and then that's good. That's an event. Whereas if these two conditions don't hold, usually it's not an event. And these are also like the two features here that really helped a lot. And the rest is kind of like, is behind. So yeah, a somewhat simplified summary of what I've told you so far. So if there are several tweets that are roughly from the same location, issued at roughly the same time, from different users, but that they nevertheless use the same words, then we can be fairly sure that something is happening there. Okay. First of all, we're by no means finished with this. I mean, there's lots of stuff where it doesn't work. And that's just something that I want to go over because it just, otherwise I think it wouldn't be right. We're working with coordinates and about like, so what we do in the first place is we set up Twitter, and we're just like having a certain location that's in downtown Manhattan, and we query like 50 kilometers around it. So there's a circular area, 50 kilometers around it, and we get every tweet that's coming in. And about 6 or 7% of those have real coordinates. The rest has some location information, but they're not coordinates. So that could be something, this is from 53rd Street, or it could be just like New York or Manhattan or any granularity that you can think of. It might also be just like a user setting up a location that's his own home, and so we have something that very frequently happens that's called Jonasland. I think it's just some guy that called Jonas, and he calls his home Jonasland, and he tweets a lot from there. So, all right, okay. That doesn't really help you because you really don't know where that is from. But if you know at least it's Manhattan or it's kind of like that subpart of Manhattan, you can use it. But yeah, I mean, we need more coordinates, or we need to take in more of the data to really figure out like where is it coming from. We don't need the exact coordinates, but pretty much. So, and one thing here is that pictures are being shared. Like every third tweet contains a picture these days. And a lot of pictures actually have coordinates, so that's a huge source. There are toponyms imposed. The toponym is a place name, right? Somebody saying, I'm at the, that and that cafe at Manhattan, and then you basically can figure out where that is. Yeah. And of course, like the posts that don't have coordinates can also be useful, because if you already know that something is happening, you kind of like know which words are used to describe it. If you find then other posts that are generally from this region, because that is what you would know, then you maybe can attach them to this cluster, although you don't have coordinates. We need something like real-time TF-IDF. TF-IDF is probably something you're familiar with. Real-time here means that it constantly changes over time. There's always the latest kind of like meme spreading on Twitter, and that might just mess up the data, but that meme is different. Of course, it changes a lot. And, if all of a sudden, something happens with Justin Bieber, the whole Twitter is talking about Justin Bieber, and then we need to know, okay, right, Justin Bieber is probably not a good word to look out for right now, because you'll find it everywhere, and it's not what we want. Same for lots of other stuff. And finally, like the recall numbers, I mentioned this earlier. If we measure recall here, we can only measure what we actually know. And what we know is the data that comes in the system and is being processed. And so once we have a cluster, we can use this as our data and use this for evaluation. But if there's somewhere a fire and nobody takes a picture of this fire, then we'll never know that we have missed this. And even if like a picture of this fire is taken and shared on Twitter, and we miss it, we never even like take it into consideration. Right? Then we also kind of like miss it, and we cannot really discount it from the recall number, which we should do. So recall number about 0.85 is way too high. So there is quite a bit of work to do for us there. Yes, there is just like a bit more stuff that we're currently being do that I want to share with you. Getting training data is always important when you do machine learning. Of course, getting good training data. In that case, we don't have the training data because, I mean, if you work on your network logs or whatever, you might just can single out certain instances and say this is good and this is bad. We can't do this. We have to have somebody looking at it and telling it to us. And what we did this manually. We can go out to Mechanical Turk, of course, but you can also think about an online machine learning model, right? That is just where you have the user sitting here, that might be a C2 operator, or also a journalist who's just interested in what's happening around him. And whenever you kind of surface this stuff to people, they interact with it and basically tell you whether this is something they're interested in or not, right? I mean, they might just have this open for a while and kind of click on the links and kind of do follow-up actions with it, or is it just this is good, or they might just click it away. This is something that you have in search engines, of course, all the time, right? I mean, do users stay on after they click on a link? Do users stay on that page, right? Or do they just come back to the search engine again? And anyhow, which links are clicked? That sort of stuff. So that's something that we're looking into. And then, of course, there is a massive other source in Twitter that you should not just overlook, and these are kind of images. As I said, a third of all tweets have images. And sometimes you have a tweet like this. This doesn't tell you anything about what's happening here. It's just somebody saying, oh my God, and then kind of sharing a link. You have to look at the picture to kind of see what's happening. So if we can do some image analysis, then we would be able to work with more tweets. So I think yes, I still have a lot of time actually, so I can show you this as well. First of all, this is something different now, but it's just like another use case that we're currently exploring, and another just like nice showcase, I think, of what you can do with all this data that is out there in various ways. And this is, as I said, we do the experiments on the New York metropolitan area, and so like everything that we get from Twitter, we basically we would also have it like for analysis. And here, that's more like 1 year of New York City tweets. And so that's 1 billion tweets, and it's more than 1 terabyte of raw data. And then what we just did is we wrote a little script that just goes over it and tries to figure out like which of these tweets are related to traffic, right? And each of these tweets is basically a user complaining about the traffic situation. So that's a map of New York road rage, what you have here. And then we have a nice little tool that actually lets you visualize this. That tool, of course, like then if you break it down and just like only extract the tweets that are about traffic, you get to something like, I don't know the exact number now, I mean, it was like, I don't know, 50,000 or so, 50,000 tweets that had coordinates and are about traffic problems. That's a lot of data, and that basically is transformed into a heat map here, but you can imagine that is kind of like that, you need a beefy machine to kind of like do this real-time computation in heat maps here, what is happening. And so I can just like show you a video of this thing. So that's just like all the tweets mapped where people complain about traffic. And we will zoom in a second, and you can clearly see, I mean, you can see the roads. And if it's zooming in closer, you can kind of like see that there are certainly some roads which are like heavily affected by traffic problems and other are not. And, you know, up here, this road seems to be particularly bad. These roads here on the side are fine. No people complaining about. This is Manhattan, of course. Like Manhattan is a nightmare traffic-wise. Here's a problem. This seems fine, and so on and so forth. And then with this tool, you can just slice and dice the data. So that's actually fairly interesting. It's just like tweets and people sitting in a car and being really annoyed by the traffic and having the urge to share it with the world. And yeah, if you aggregate it, that's the outcome. All right, fair enough. I think that's it from me. Yeah.